I just want to say hello to everyone and welcome to this Equal Experts Client World Tour, basically where the purpose of this is we invite a range of our clients from all the continents around the world, where we have clients on to come in and basically give a talk about topics of their choice. And if this is your first time with us to any of our events, we do expert talks as well, which are normally monthly based on location. Equal Experts is a software consultancy, and one of our passions is making sure that we give back to the community by running these types of events. They used to be pre-COVID, they used to be in the flesh with a bit of beer and pizza. Now in the COVID world, they're all virtual with lovely backgrounds, which I wish this was my office, but it's not quite. That's a bit more like Tony's office. So these go on, and if you go to the Equal Experts website, you'll see different versions of these going on in different places, different time zones. And we try and do this so that it covers time zones both here in APAC, across India, Europe, and UK, and even America, if we can make those times fit in. I'm Andy Canning, and I'm the technology principal here in Asia Pacific, and I'll be hosting this evening. Our speaker today is Rohan from Xinja Bank. Zinger is a 100% independent neobank based here in Australia. It was one of the first banks in a very, very long time, and I'm sure Rohan could give you the exact details to get a new banking license. Xinja is also our longest client here in Asia Pacific, who we've been working with since their very initial inception. Rohan is a co-founder and head of architecture for Xinja. And today, as you can see from the slide, he'll be talking about the Xinja event architecture, which is actually a topic very close to my heart since I've been involved with Xinja for quite a long time myself. We'll have some Q&A time at the end. So if you have a question, I think some of you already found there's a Q&A option within Zoom. If you ask your questions in there, what we'll do is we'll cover them at the end of the talk. So on that note, I hope you all enjoy this talk, and I'll mute myself and hand you over to Rohan.
Thanks, Andy, for that introduction. And thanks to Equal Experts for the opportunity to talk to you all. I'm certainly missing the beer and pizza, but there'll be ample opportunity for that in times coming, I'm sure. So yeah, as Andy mentioned, Equal Experts have been working with Xinja since the very beginning. You know, when we only had one or two people on the ground to build out our technology landscape, and that was, I don't know, probably about 3 years ago now, I guess. And since then, they've continued to provide delivery, analysis, architecture, thanks Andy, and engineering resources over time, and that's been both onshore and offshore, and even to this this continues to the current day, and they continue to be a critical part of our delivery capability. So thanks again for the opportunity. So Xinja, Andy, as Andy mentioned, 100% digital neobank. We received our banking license about 12 months ago now, having had some lead-in sort of products prior to that date. But basically here we are here to disrupt banking, not only as a 100% digital and in the cloud bank, but also delivering product innovation. So far, we're the first to deliver a no strings savings account in Australia, and also the first bank to, or we will soon be the first bank to integrate with a US share trading, or a US share trading product, which we're calling Dabble. And that'll give customers access to the US stock exchange, including fractionalized share trading. So we are here to really try and think about how banking can be done differently. Before I get into the detail, just thought it'd be worthwhile just giving you a very high level picture of our technology landscape. we're built on principles of having no legacy and deploying cloud-only solutions. So we don't have our own data center. Anything that we build ourselves runs on AWS in our own tenancy, and we have a suite of third-party solutions that we integrate via that platform, which we call affectionately the Xinja platform. And so all of those third-party solutions are software as a service. So we do not, as I said, have any on-premise infrastructure at all. And our platform, our only channel, by the way, is for day-to-day banking, is our mobile app. And that is interfaces with our platform, which is effectively a microservices and event streaming stack hosted on AWS. The microservices themselves leverage events to integrate third-party solutions, and they're built either and deployed in Amazon EKS as Docker containers, or as serverless functions, primarily using Lambda at this point. In addition to that, really the focus of today's talk will be this little area down here. So we use Kafka as our event streaming solution, and that is using the Confluent hosted Kafka solution. And finally, Kong is our API gateway, and in the coming 12 months, we'll be rolling out their service mesh as well. Events. So I think, first of all, just to set a bit of context around what we're talking about today, events are messages, in effect. They're generated whenever something happens on our own platform or in any one of the systems connected to that platform. So examples that I've just put up there, a customer is created or updated, or an account is created or changed in some way. In addition, it could be a transaction happens, like a payment, someone uses their card to actually make a payment at point of sale, or sends a transaction out, or someone applies for a loan, or someone does a EKYC check in very banking specific concept there. They effectively represent a point in time state for a particular object of data. They're streamed from systems that generate them to systems that want to use them. So as you can imagine, we produce a lot of events. So, and the systems that produce events can be anything from, apps. Our mobile app can produce events. Third party, we're implementing a loan originations solution at the moment that produces a large number of events whenever someone progresses through an application. Our core banking product, right, as you'd well imagine, lots of events, microservices. And then in turn, these systems can consume those events as well. If we want to, based on something happening in one system, another system wants to consume those events. So basically, we use Kafka to manage the event streaming, and that's a solution that allows systems to produce or publish events and to receive or consume events. So it does this in a way that separates the producer and the consumer, and both can operate completely independently from one another, and consumers can operate completely independently from each other as well. So you can have many consumers of the same event. Each consumer can do this at their own pace. So for example, a high volume producer of events we might have multiple consumers. Some might want to stay up to date with the events as soon as they're produced. And then other scenarios where it might be okay to have a bit of lag with event consumption, that over the course of 24 hours or a week or whatever, eventually you're catching up to take into account peaks and troughs. It does give a lot of flexibility. Additionally, consumers can choose what they want to consume. Some consumers will be interested in every single customer updated events, everything, because they want to create everything. They want to know everything about a customer. Others will be only interested in a particular data item has been updated on a customer. So they can be highly selective in terms of what data they actually consume. So Kafka itself is reliable, scalable if configured properly, and most importantly, really, or not most importantly, but very importantly, each message can be retained in Kafka going forward. Confluent hosts, we use their hosted Kafka solution. We did, in our early days, stand up and run our own Kafka infrastructure. It takes a lot of maintenance to keep the lights on, we found with Kafka, and manage it and make sure there is sufficient capacity and resources supplied to it. So after a while, we made the call to shift across to Confluent, who do that very, very well for us. Not to turn this into a Kafka 101 lesson, but this is an important concept. So every Kafka uses what we call topics to hold events. So these are similar to queues in JMS or MQ or something like that. So, and you can define topics however you want to define them. We typically define them related to a domain or a business object or something like that. So a customer topic and an account topic. But equally, you might have more event-driven ones like a notification or a command type topic where you're trying to send a notification out. Again, just to support that asynchronous processing. So producers always append an event to the end of the topic, and consumers maintain their own pointer to where they are on the topic in terms of where they're up to with the consumption. So each consumer tracks their own offset pointer that determines where they're up to. Any consumer can restart, set it to 0 and restart at the very beginning of time, and then consume all events. And that's an important point that I'll discuss more later. Essentially, the topics are a log, and in that way, events are immutable. Once they're in there, they cannot be removed. I mean, you can configure the topics to be removed, but you can't update an event. So it's important. That's a very important concept as well. So, and what I will repeat, events are retained in the topic as well. And that is very important for, and Andy has given a talk on this previously, for the event sourcing pattern. So how Xinja uses events? So we use event sourcing heavily. And what that basically means is that the topics themselves become a system of record for event data. So with that little teaser, I'll just take a step back and at a very high level. So we have third-party systems like SAP, our core banking system, C4B, cloud-hosted core banking system. They produce events. These two systems here, ChargeBee and DriveWealth, they produce events in relation to our share trading product, Dabble. We have payments coming in from GPS, our payment processor, MasterCard, and then also the digital pays. Our help desk software sends events in, and also telephony as well, and then our eKYC providers as well. So they're producing events. And then we also have our Zinger app itself, and it produces events, from payments, onboarding, how, and at various points, if a customer wants to lock a card or unlock a card or order a replacement or whatever. So they're coming out of the app, and then other microservices as well on our platform. So they'll produce events. Event sourcing, all of those events are retained in a topic. We never throw away any events. where required, we order those events. So Kafka does have the ability to define a key so that whenever an event is appended to a topic, it is in order. So for example, a customer identifier, we have events from the first time a customer was created sitting in the Kafka topic. And then every time a change is made to that customer, that's a single event in the Kafka topic. So we have consumers of those events that then build their own view of that object, of that customer. If they want, and then if they want, they can completely destroy that local cache and replay all of those events to reconstruct the current state of that particular object. So multiple consumers will then build their own view of that particular object. So I've sort of touched on the consumer side. So the same producers of events equally can be consumers of events as well, or other systems as well. So we'll have payment events coming out, and we'll actually, events coming out of our core banking system, and then we'll, and I'll go into more detail in the next slide, but we'll then have those available for consumption by any number of consumers. We also then, I've talked a lot about the event sourcing. We also then have more command sort of type patterns where we'll send a notification out to a third party. For example, Airship we use for our customer engagement and communications. So we'll, when a particular sequence of events or combination of events take place out of our producer systems, we will then trigger a notification out to a customer, or we'll trigger an update, to their AML. We'll recheck for AML purposes under certain circumstances, or certain payment events might trigger a fraud assessment as well. So these are all sort of those notification type concepts. And then others, we have the event sourcing, which I have touched on. And that's thanks to Martin Fowler. So if you want to learn more about event sourcing, he has documented patterns as well, and there's plenty of reading material around in relation to event sourcing itself. So additionally, all of our events are streamed into our reporting and analytics solution. And so that basically allows us to have near real time feed of data into reporting, and that's very, very important for us to be able to give very up-to-date views of data to our business representatives. So just to then show you a more practical example for customer and account data. So we've got here scenarios. So we've got topics for accounts, transactions, and customers. So our customer master is actually a Kafka topic so we've gone, that's full event sourcing there. So we've got a microservice that applies all of the business rules, business validation. The persistence layer is actually Kafka. So any downstream service that actually requires a view of customer then plays those events into their own local cache. We typically use DynamoDB for those purposes. So in this particular example, we've got our Customer 360 service. So this is a very important service for us. This basically consumes events from customers, transactions, and accounts, and other sources, card information, other eKYC information from other topics as well. It brings all of those events in, and it builds a cache, right? So this is not a master, right? This cache never changes. If we need to change data here, it's replay events or consume new events from source. This is just a read-only cache. So what the advantage here is, so you can imagine in more traditional architectures, you might need to bring a lot of data as structured for optimized for transaction processing perhaps, or for reporting or for reading. So the advantage with event sourcing, the way we use events, is that each consumer can structure the data in any way that it wants. So we've been able to tune this database here, this read view here, based on events that are coming in, highly tuned to a very quick lookup of data, or everything we know about a customer, so that we can then very quickly surface that full view of customer in our customer servicing platform, which is called Zendesk. So in context, whenever a customer calls in, we pop up all the customer's personal details, their accounts, transactions, cards, whatever, so that our customer agent, service agents, straight away in front of them has everything that they need to know about that customer, without having to go back to core banking, without having to go to our our eKYC solution, without having to go to all of the other places. We've managed to bring that together in a highly tuned and efficient manner to surface that information in Zendesk. But that's different. Our app consumes the same data, same events, but structures them differently. So when someone logs on to the app, we get customer details. Just want to get the customer details. But then at a different point in the app, we'll get account details. So that's a separate read view, right? So these are other caches of the same information, but much more targeted to what the app requires. So this is a really important concept, because these services here are sacred. So these are our main customer channel is, as I mentioned earlier, is the app. And we want this to perform, and we want this to be a really excellent user experience. And I think we have done very, very well there. And so basically these are almost, you can think of these as the server-side components to the app. These are not used for any other purposes. And these are, and they obtain the data that they need to perform the very specific task that's assigned to them for the app. And if we need to make this change, we can change this. Easy, change it, replay events in, without impacting the Customer 360 service or whatever other services around our infrastructure uses customer data. So it gives us a huge amount of flexibility. And if for whatever reason we have another service that needs to reconstruct or an intermediate state, then we can do that, because we've got a full history of events in our topics up here. And I haven't shown it here, but just to sort of touch on that last point, again, our reporting and analytics solution takes all of these events as well. And so you can think about it, we've got every single event since day one. So our reporting and analytics is able to aggregate to whatever level of granularity is required. That could be put down to the minute level if we wanted to. It could be up to the hour, could be up to the day, the month, whatever is required for the analytical requirements at the time. So what's the big deal? What are the benefits of this approach? So the first is really, it's not new to event processing, but there is the decoupling and asynchronous processing itself has a lot of benefits. So one system can perform and scale completely independently of another, and also knowing that the events are stored in Kafka and they will never be lost. So this allows a drastic improvement in terms of reliability. So we can make changes or even have outages on one system without affecting other systems. And that then feeds into the CQRS pattern, the command query response or separation. So we can send events into our infrastructure for updates, thinking about that customer master example. Our onboarding systems can create customer records, and then they can go off and they're not waiting for all of the validation logic and things like that to take place. So there's scalability benefits here. And then when they need the data, they can read the data completely independent of the write step. And equally, we can optimize the read independently of the write. Future-proofing. Now, this is one that we sort of discovered as we built out our bank. By having a full history of all of the events, it means you can effectively delay decisions. And because you're capturing historical data, so you're not reliant on forcing decisions at a point in time. You know, for example, a business might not have thought through what they need in a particular domain. So, okay, well, let's just hold off on that. But in the meantime, we can continue to hold on to all of the customer and account information and whatever other data that we have. We can continue to hold on to that. And then when we're ready to make a decision on something, we can then just play in historical data quite easily to build a current state, to implement a new system or new reporting requirements or whatever. So this has been very helpful for us. For example, you know, for CRM, we've been able to really build out our full view of customer using all of the event data that we are gathering. And it doesn't force us to do that very early on, so we can then start to accumulate historical states. And that's the very important part around you know, the difference between this and say you know, monolithic systems, where a monolithic system, you've only got the current view of the data as it sits today. And yeah, it's very difficult. You have to go into, you know, unless it's specifically engineered to retain a change log over time, it's difficult to get that, right? And for reporting and analytics, maybe you have to take daily exports from a monolithic system to feed into your data analytics solution or your data warehouse or whatever. With events, you don't have to worry about that. You've got the full history of that data to feed into a new system, whatever. And feeding into new systems, so it does make, if you do need to make changes in future, full data sets can be built very easily for a new service. For example, if we've got a new feature that we're building in our app that needs to say, you know, if customers matching a certain profile based on behaviour in the last 12 months, it's very easy for us to build out that historical profile and feed it into a new service and then start applying benefits from day one. It's all about replaying those events for new requirements as they evolve. And think about then in terms of migration. So if you need to migrate from system A to system B, it's much less about extracting data from system A. It's about, and then importing into system B, it's about replaying events into system B. I've talked about the improved and scalable performance. You know, that database design for those read view caches, they're tailored to whatever the specific use case is at the time. I don't have to cater for multiple and contradictory requirements. You can do it exactly for what you need. We can, and I think I've probably talked about that particular benefit enough in earlier slides. So the next one is around being able to reconstruct how we arrived at the current state. So again, if you think about traditional approaches, you've got, you know, the current state of an object, right? We've got, you know, an account balance. I can't help but go back to the banking context, and this is something that we find very useful. So you've got an account balance, but what was the path? What was the transactions that led to that particular account balance, or a customer's state? You know, what if you've just got the current state, you don't know. You could have multiple paths to reach that current state. And it's often very useful for analytical purposes to understand what were the different ways, different paths that were followed to reach that state, because you're interested in optimizing potentially end user experience. Right? So you could have needs to roll out new features based on to deal with poor user experience earlier on. So it really is that full end-to-end context over time. And as you're probably gathering, it is all about the data. So really, when from the very early days of Xinja, knowing that we were capturing events just made it very, very, it reduced the risk as we built out our platform of making incorrect decisions, because it makes correcting those decisions much simpler, because you've got the data, you can correct the state of data, and you can feed it into new features and new services down the track. So, but it's all about the data. It's a hugely rich data set. It's not hidden away in monoliths. It's available to you in those Kafka topics. It can be played out very easily into whatever consumer needs it at whatever point in time, in the historical journey. We can rebuild the state of an object at any point in time, not just the current state. And we can combine events from multiple sources to build a new version of an object, and then that can generate its own event as well. And that is what we actually do on our platform for various purposes. And so you'll probably ask, that is a lot of data, right? And yes, it is. It is. It's a huge amount of data, and as we grow, it will continue to grow. But and I think, and I've quoted Greg Young here, who has a really good YouTube on event sourcing. The value of your data. How can you gauge the value of the data that you are gathering, and how can you say that is more or less valuable than the cost of the storage? Because that's really what the equation is. Why do you throw away data? Because it's very expensive to keep. So how can you say that the cost of that storage, especially now we've got cloud storage, AWS continues to offer cheaper storage. Yes, it's offline, but still it is there. How can you say that is more or less valuable or more or less expensive than the value of the data itself? Data is one of that, especially data generated by an organization, is one of its most valuable assets. And for us to continue to be able to deliver innovative products and services to our customers, this is one of the most important things that we can possibly have. And you think about transition states, all that sort of stuff. How do we get here? It's very, very valuable. So I would say, it is definitely worth the investment in the storage to hold on to all event data as much as possible. So that's it. It's brief, but that basically sets out how we use events at Xinja, and it's really that. Just to sum up, event sourcing is very important for us, being able to provide those optimized read views to our app and other consumers, or to other, to deliver those innovative features that we need. And again, it really is about, I do recommend as much as possible, hold on to your events, never let them go. And really leverage the benefits that gives you in terms of your analytical capability and new feature innovation as well. So thanks very much. Over to you, Andy.
Thank you, Rohan. Thanks a lot. So what we'll do now is dive into some questions here on the Q&A. There's a number of different ones and people have been voting on them. So we'll start off with these then. So the first question, Jay Christian. Seeing your heavy users of AWS, was Kinesis considered as an alternative to Kafka, externally managed? Interested to hear any perceived shortcomings of Kinesis. So this is basically a question about were there other options considered around the Kafka implementation, which obviously Kinesis is one of the first ones that pops into mind since there's a lot of AWS around the platform.
Yeah, sure. So we did consider alternatives. We did have a good look at Kinesis. Now, remember, this is what, a couple of years ago, I think, 2.5 years ago, I think. At the time, Kinesis had some constraints, and from memory, it was throughput constraints at the time, and I'm not sure, to be honest, whether or not they still exist. But at the time, they had some upper limits on the number of messages that they could process at a particular point in time. So that was probably the biggest factor that drove us down the Kafka path.
Yeah.
But yeah, having said that, we did look at alternatives, and then we did some proof of concepts on Kafka, and it served our needs very well, and has continued to this day.
And I think that's part of the point here as well. Is the, like a lot of these things, when we're doing a lot of stuff in the cloud these days, it's all down to when decisions are being made. You know,
Yep.
perhaps if an evaluation was done today, certain things would be different, but it's about where you're at the time, and then you have to, you commit to something. Not that it means it can't ever be changed, but it's about at a point in time, some things aren't always quite mature enough.
Yep. And that's a good point, Andy, because another example of that is EKS, right? So we started out with our own Kubernetes infrastructure, and we have now migrated across, or we're in the process there of migrating to EKS, and that's a demonstration of Amazon investing in their capabilities, and so who knows? Maybe Kinesis now has removed those constraints that we saw back then.
And another question from here from Peter. How will event volume be handled over time? It's expensive to keep all online in high-speed storage. Will this impact the event sourcing mechanism?
Yeah, that's a really, really good question. You're right. The persistence layer, it's S3 for Kafka and on AWS, and is it actually? I might have told a lie there. Anyway, I'll stop trying to be a Kafka expert, but at the same time, so what it basically is that is where we have one of the main reasons why we moved over to Confluent. So they have implemented an abstraction of the storage layer underneath, so that they are actually able to persist off to cheaper storage under the covers for aged events, if you like. And then if we need to replay events for whatever purpose, they are in effect able to rehydrate the topics from the offline storage to the online storage for us to then replay the events as need be. So that's a very good question. So we have and that was an issue for us when we were managing it ourselves, and that's an important cost consideration.
Great. Next one from Michael. What strategies do you apply to manage the structure of events changing over time?
That's a good question, and it's versioning is important, and also shared libraries, basically. So for our customer topic, we have lots of consumers of our customer data across our platform, and we have built out libraries that are shared across all of those consumers that basically implement a pipeline to consume events right to read view. And yeah, so they're probably the main strategies that we have done.
Okay. Just seeing what there is in here. So there's quite an interesting one in here, I think. I'm just going to skip down, which is, do you have to deal with transactional consistency between Kafka and other data stores or message systems? That was happened to also be from Peter, but I think based on your initial diagram with all of those, basically a lovely bunch of spokes sticking off the side of the diagram, I think this is probably something that's quite apparent for Xinja.
Yeah, absolutely. And because we do have, we serve up data to our app from read views. So yes, we do have to manage that, and there are circumstances where we, in effect, have to do reconciliations across different areas, just to ensure that everything is is aligned. And we have various mechanisms for doing that. But yeah, it is an issue for us. But generally, if there is within, a transactional boundary, if you like, that really needs to be honoured, we'd try and keep that within a single service. So a single service would potentially read and consume off the same topic, and maintain its own internal state. But it does become challenging when you've got distributed logic, if you like, across multiple services, to maintain those sorts of rules. But we found, certainly to date, that we've been able to manage that through consumers by the approaches that I've mentioned.
Okay, so there's another interesting one here from Mike. Just a question with Kafka and event sourcing. From what I understand, it's not an event store, nor should it be used as one, as it doesn't support optimistic concurrency. How do you handle this?
Certainly in our circumstance, we haven't had any issues, and it's certainly a pattern that Confluent have published as well, in terms of it being used as a persistent store for events. In terms of, yeah,
I think this comes from, if you can correct me if I'm wrong, Rohan, as well. I think this comes from the implementation of Kafka streams. So I think within the platform you have Kafka streams, and you have basically state stores, and that's what means that then you can farm off and sort of localize those that state. Is that correct?
yeah. Well, that's pretty much what we do with our read views in themselves. So the state is managed on the consumer side pretty much entirely. So I'm not sure whether that answers the question.
Okay, I'll let Mike come back to us. So there's another one from Abdul, which basically says, you don't delete events, so won't you have performance issues over time going through your old events, or do you use snapshots at particular points in time?
Yeah, that is something that we are working through at the moment. So we can, using the AWS infrastructure, we're able to scale up resources on consumers when we're replaying events. But yeah, that does absolutely become an issue, and we're looking at snapshots at points in time if need be, and that's potentially an approach as well, like in terms of GDPR related issues around forgetting data or whatever. It's that is an issue because of the immutability of events, and we're looking at strategies around that, potentially using pointers off to other data stores as well. So you sort of get the best of both worlds. You get the events and the ordering and all that sort of stuff with other data stores that allow you to actually remove data. and that sort of approach could potentially be used for snapshots and things like that as well.
Cool. I think there's a couple of interesting ones here in terms of not necessarily just about Kafka, but about platforms and architectures and systems as a whole. So I'm going to pick a couple of those. One was from Lee, which is, how do you integrate with third parties who have legacy systems that may not be compatible with event-driven architectures and such modern practices? Do you surface this via REST calls or some other technique for legacy third-party integrations?
It depends, really. Ideally, we always try and get our partner systems to generate events, whether that be via webhooks to us. That's the ideal scenario. And so obviously we're then it's just a simple RESTful endpoint that we expose, and they just ping us with events. And that has to be, you have to be careful there to construct it in a way that you're not holding up their environment while you're processing things on our side. To make sure you just persist an event and reply. And so you're basically decoupling the receival of events with any downstream processing. That's not always possible. We've got providers that we've had to swallow a bitter pill and take a file feed. But then we basically convert that into events as well. Other scenarios where we might have to poll. So they're the real fallback options, but polling is inherently risky, and is not something I would recommend for high volume scenarios. If you've got a low volume partner or scenario that they only expose APIs or web services or interfaces that you need to connect into out of your platform, then that's an option. So pull it in right to a topic, but then that means you've got to track time and all that sort of stuff, and that's much more difficult. So only if there's no other option would I go down that path.
Well, Rohan, just to give you a break from all the tech questions, I've got a business related one. The fact that it's an immutable store and it acts essentially as a log, did that help you when you went through all the compliance and regulatory aspects of becoming a bank?
Yeah, it does. Because it meant that for example, the provisioning of customer data, that we're obliged to provide to APRA, for example, it helps us construct those data sets quite easily. And then in general, even in terms of the logging, for example, being able to prove what has happened on a particular object, that is all supported via this pattern and was a great help to us as well.
So it helps satisfy a lot of the controls that you need to put in place.
Yeah, that's right. That's right. If you think about the risks related to fraud, for example, you're able to then go through and reconstruct exactly what has happened in a particular scenario. So yeah, definitely, a lot of risks that we have to control all over the joint, and this approach does assist that. Yeah.
Cool.
And there's another interesting question here as well, on a slightly different angle as well from Ben. He goes, with such a dispersed system, how do you maintain an overview of its health?
Okay, that's a very good question. So we've got, I mentioned Kong Mesh earlier. So that's something that we're looking to roll out in the next 12 months. So they have the ability for centralized management of a microservices architecture, and also they will be rolling out plugins into Kafka as well. So that's sort of that centralized management of security and other type of policies around, say, retry policies or something like that. So being able to, and then even in terms of inter-service permissioning and visibility. All right, so it gives us those that as well. But then we've got monitoring solutions. New Relic, for example, is one that we're heavily reliant on. So that gives us a lot of visibility into the platform in general. For example, monitoring queue depth or topic depth, or sorry, lag. my history of, I think it's MQ history is showing here. So topic consumer lag is one thing that we do monitor, so and alert on. So if we have, for example, our reviews for our apps, if they're falling behind on consumption, we'll flag alerts out to our support guys, who will then go in and work through whatever issue is causing that lag. So that's probably a major solution. And then we have other solutions to monitor and alert for security purposes as well. And then for technical logging also, and alerting associated with sort of error logging and things like that.
And then there's an interesting microservice question here. How many microservices do you use? A bank based in London has about 1,600.
Right.
I thought that might make you smile.
I was going to say, is that all? Yeah, no. Look, we're trying to think. We're not up to 100 yet. We're under 100, but this is an area where we do need to be careful with proliferation. We have sort of taken a move to domain-driven microservices, keeping them fairly coarse-grained at the current stage of our journey. And I'd say the same for topics, Kafka topics. So having a customer service, an account service, and topic. And so that's certainly where we started. And over time, as we need to separate those services into more fine-grained services, we're able to then make that decision at the time. And we've started doing that in our customer space, mainly related to the topics. So we've still got a single service, but now we've started to break out the topics into more specific purposes. That's because we're finding our main customer topic is with the main customer data set is much more stable, and then we've, alluding to an earlier question, we have now lots of consumers off that topic. So change to data in that topic is causes more downstream impacts. So we're actually now happily at a point where that can remain fairly static. And as we have more data sets coming in related to customer, but they're more ancillary communication preferences, and other status type information that we're able to then feed into separate but related topics. I think that answers the question.
It sounded very, very thorough to me. And I think this is a follow-on from a previous question, really talking about how, previously it was asked, how do you integrate with systems that don't support event-driven mechanisms and architectures, etc. There's a question here from Peter saying, do you have to deal with transactional consistency between Kafka and other data stores or message systems? And I think before you mentioned the word reconciliation, for example. So, what does that mean to Xinja, that reconciliation and that transactional consistency?
Yeah, well, and that's where this has been the same with distributed systems since the day dot, even in SOA days, dare I mention SOA. The same problems exist where you've got, you might need consistency across systems. Strategies there, you don't have, the optimistic sort of locking sort of, that you might have within a monolith, or two-phase commits or whatever. What you've got is the need for compensation, rollbacks, and with further controls around reconciliation. So if something doesn't succeed on one system, okay, let's do some retries. Let's order the sequence of events, in a smart way, so that if one fails, we can just stop there, and maybe we don't even need to roll back the earlier steps. But this is the same with any distributed system where you've got multiple steps involved. You need something, you know, if you need to have transactional consistency in that way, you do need a service to coordinate that and track state and roll back if need be. You know, send in compensation transactions or whatever. You know, so if you've got a change coming in triggers updates on 3 different systems, you know, then track those updates, success or failure across those different systems. The last update fails, catastrophic, you know, critical failure, you're never going to get it in there, leaves it inconsistent in the other areas. Okay, let's then roll back, do compensation transactions on those earlier systems. If they fail, then you've got an issue. Raise an alert. Someone needs to actually go in and have a look at what's going on. You know, you've got a pretty critical issue if that whole set of steps falls over. But that's the same. That's not new to this pattern. That's the same with any distributed system.
Okay, I think we've probably got time for maybe one more question. I think a question that might be interesting here is from Abdul again. Your event store is very important to your business. How do you make it more resilient? Is it multi-AZ, multi-region? You know, what's the resiliency pattern there?
Yes, all of the above. And again, Confluent, you know, their hosted solution is AWS hosted. It's cross-region, cross-AZ. With Kafka, setting up availability groupings, with the Kafka broker set up, you know, we're able to set it up in a way that you know, topics are replicated across availability zones and regions if need be, and you do have a fair bit of flexibility in terms of how conservative you want to be with that regime. So you can, the consumer or producer rather, can hold a thread until it is completely persisted across all of the partitions, across all of the availability zones or regions, or it can be a bit more optimistic and go on with its work, you know, and leave it up to Kafka brokers to take care of all the replication. So, but long story short, you know, that all the Kafka events are replicated across regions, so that if there is an outage, you know, we've got one region, we've got other, the data is still up and running and available to us in those other availability zones and regions. We do also actually back up topics as well. You know, if they're in the absolute worst case, there is corruption in a topic at any point in time or whatever, then we're able to restore from backups as well. So we've got multiple levels of recoverability there.
Cool. Okay then, well, I think it's pretty much on the hour now, so a good time to wrap up. For everyone to know, the next talk here in Asia Pacific is by another Rohan. We only ask people by the name of Rohan to do talks for us.
All the cool people are Rohan's, right? Yeah.
Rohan Berry, who's the head of digital IT at Big W. He's basically doing a talk about migrating from monolith to microservices. And that's on the 28th of October, I believe. You can find it on our website. So lastly, I just want to say a massive thanks to Rohan for coming on and talking to us very lengthily and very eloquently on basically the Xinja architecture. And also thank you very much to everybody who's come on and listened and got involved and asked questions. So thank you all very much for joining. I hope you all have a great night or day or whatever it might be, whether it's evening, morning, lunchtime, or whatever else, wherever you might be, depending on where you're joining us within the world. And hopefully we'll see you again or not quite see you, but hear from you again on another one of our talks. So thank you very much, everyone.